Mass and energy balance for biosystem. Model 10 Energy and mass flow through ecosystem. Segment 2 Primary production. It's me, Lily from School of Life Sciences and Technology, Institute Technology Bandung. In the previous segment, we already discussed about the energy density. And in this segment, we will focus on the primary production. Primary production is the amount of solar energy captured as chemical potential energy by photosynthesis. In concept, this is very simple, but in practice, this is very difficult parameter to measure. The gross primary production, or GPP, is the total amount of carbon fixed per unit area per time. And the net primary production, or NPP, is the amount of organic carbon and other biomass that remains after the autotrophic organism has met its metabolic needs. And the herbivore are consumed by secondary consumer or carnivores who may be consumed by tertiary consumers that we call as carnivores. Primary production is the single most important variable to know, understand, and design in an ecosystem. All energy within that ecosystem derived from primary production we called as autochthonous production, and energy introduced from outside the ecosystem boundary, such as from animal immigrating into the system, with the debris flow into the system, or the mass flux phenomena we called as alloctonous. Organisms only digest a portion of the food they eat, passing the rest through as vessel to be consumed by the herbivores. And the assimilation efficiency is the amount of food assimilated relative to the amount that ingest. Animal biomass is more energy dense and digestible than plant biomass. Thus, the predator efficiency of conversion can range from 60 to 90%, but the herbivore conversion rates is about 15% for high cellulosic material to as high as about 80% for seeds. Exploitation efficiency is the ingested food divided by the prey production, and the net heterotrophic production is the ratio of the biomass accumulated through growth and reproduction over the assimilation biomass. And the gross heterotrophic production efficiency is the net production divided by ingestion. Ecological efficiency is the consumer production divided by prey production. Understanding the ranges of productivity for a given area is critical for effective ecosystem services design. The most productive unsubsidized solar-powered ecosystem, tropical forests, produce about 1.75 kg per meter square biomass through net productivity, while the subsidized solar-powered ecosystem, such as wetland, can produce as much as 2.5 kg per meter square biomass as shown in this figure. The biomass accumulation ratio is the stored biomass divided by the net productivity and expressed as the year's accumulated biomass. The factors that affect primary production include light, temperature, water, nutrient, and space. Organisms in a place compete for these factors. The way they complete results in a set of life strategies for growth and reproduction. Uh, Plants analogy adapt to light intensities depending on the availability of light for the place in which they exist. Many plants grow tall fast in order to capture light, resulting in significant investment to support biomass. Others have adapted to the light limitation by increasing their photosynthetic efficiency. And the amount of sunlight necessary for a plant to meet its respiratory needs is its compensation point. In many plants, this is between 1 and 2 watt per meter square. The potential for designing high-energy systems using unsubsidized solar power is rarely sunlight limited, but more often water and nutrient limited. The energy density of desert is very high, for example, then the net primary productivity is very low. The design parameter for primary production must include limiting factor as condition for performance of the system. Water is the most important limiting factor for primary productivity, and also the nutrients are most critical in limiting primary production. Nutrient requirements for plants are generally grouped into macro and micronutrients. In the next segment, we will discuss about the designing tropic levels. Until then, I'm Lily from Institute Technology Bandung.